Hey coding owls, welcome back to the channel. This video I am going to explore something very important, that how does Git stores your commit. Now this is nothing but Git internals, and let us explore how does it does that. So usually we know that we have got three major working areas in Git. We have got working directory, we have got staging or the index area where it's like a launch pad. We keep our files here before committing it, and repository is the area where we actually make the commit. Now if you see, I have certain files. What are my files? I have got index.html, I have got a styles.css file, I have got two images, Git and Java PNG, and the structure of my application basically looks like this, and this is how my initial file is looking like. Now my plan is I want to commit this and make this as a Git repository, and from there I want to make the commits and record all my changes. How do I do that? So I go to my repository, or the place where these files are, and I open my git bash here. Given that you have already installed git bash, and let me open git bash in half and half mode. So, and before that, let us quickly just make the changes to the font. Okay, I apply these changes and I just structure it here. Now, the very first thing I'll do here is I'll say git init, which will help me initialize my repository. Now, I have kept this aside because you see, the moment I initialize the directory or the repository, what happens? A folder by name .git is created here. Now this .git folder contains what? This is the place where all your things of Git are kept. So we have got hooks, we have got info, then we have got objects. Now this is an important folder which we are going to explore. Then we have got refs, and this basically contain your branches. Then we have got config, description, and head. Head basically displays what is your current branch. So at this point, I want to explore a folder by name objects. If you see objects, we have got info and pack, but this is the place where all your commits are basically stored. So if I go to git add space dot, that means I am making a structure. I'm just putting it into my commit. So at this point, you see they created some structure, folder structure here. And at this point, I also go and make a commit. I say git commit -m, and this is going to be my first commit, or this is my boilerplate code commit. So the moment I make the commit, you see certain directories are increasing here. That clearly means that we have added some commit file, and these files are nothing but stored as a history here. There is a command which will help me to know the tree structure of my Git files or my Git commits. What is that command? Git cat file. Okay, git cat file. And okay, before that I need the SHA-1. So how does that look like? See, I'll do what? I'll say git log. Now git log will show me what is my SHA-1 hash for my git. So here you see they have given me a hash. Yeah, they have given me a hash. So one thing which I want you to understand, if you do git log and if you look at the commit, see the SHA ID is being shown here, and this is nothing but my commit ID. So my folder is structured in a way that the first two character of my commit ID, there will be a directory by that name, and then inside it there will be more folder like a file which will be starting from the like the third character onwards until the end. So it starts with 2685, see 2685, and end with B1 B5. So that is how your folder internally for with this commit ID looks like. So this hash is what I want to copy. Now understand, for every commit which we do, we get this commit ID. This commit ID is nothing but SHA-1 hash. So if I go to here and if I see, this is the root of your Git repo. And when you do SHA-1 hash on this particular thing, it gives you an alphanumeric value. Now this is unique. This is unique, irreversible. So this is like an identifier for that particular Git, which no one else will. It is universally unique. So this is what you get in the first go. Now, if you go ahead in your Git bash and you say, let us try to open this one. So if I say git cat file -p, and if I paste this SHA hash or my commit ID, you know what does it say? That there is a tree inside this, and author is me, committer is me, and it will give me what time it was committed with what time zone and everything here. and this is my first commit. It is also giving, this is how it is showing my commit. Now you see it is saying that this is a tree which is for this particular one inside my commit. So this is the ID of my commit. So here, let me see, I'll show you what is the type. So I say git cat file hyphen t. Now see, hyphen p stands for pretty print and hyphen t stands for type. So if I put my commit ID, if I put my commit ID here, I don't want to copy this. But I want to show you first. If I say this is my commit ID and if I put it with hyphen t, it says this is a commit hyphen t. What does it say? It says it is a tree. Now what does this mean? This commit, this tree, these are nothing but the objects inside git. Now what are the various objects available inside git? A git contains commit, a git contains a tree, a git can contain a blob. Blob is nothing but the actual end file. For example, index.html, git.png, these are the actual blob files. We'll go and see that. Then we have got tags. See, we have got tags here. So tags are something which we are not going to cover up, but there are 4 git objects. What are those? We have got commit, we have got tree, we have got blob, and we have got tags. Okay, so these are my 4 git objects, and on this git objects what we are going to do is we are going to use our current flow structure. We'll understand based on that. So what I do is I open. So I have already done that, but let me just quickly clear this. And at this point, I go inside that tree. Hyphen p will give me the internal structure. So when I go inside this tree, see, it is telling me 3 things. First, there is one more tree inside it, which is nothing but my images directory. And then there are 2 blobs. What are those? Index.html and styles.css. And every one of them have got this SHA ID. Every one of them has got this SHA ID. See, first 7 characters are more than enough for us to explore this. Yeah. So what I want to do is I want to just create a graph of this based on what we see online now. So git log hyphen hyphen one line. Okay. Git log hyphen hyphen one line. What do I find? I have got first commit and it is looking like this. So based upon the internal structure, what do you see? We have a commit. From that commit, we have a tree, which is coming to what? F23193B. Then inside that, we have got one more tree, which is for my images. And then we have got 2 blobs inside them. And then I can say what git cat file hyphen p. And if I open this tree much more, like if I go and say I want to copy this and paste it here, enter. So it gives me 2 more internal blobs. So I have got what? This blobs. Let me see how this look. So remember, I'm using red color for commit, green color for tree, and this one for blob. So I'll put them side by side, both of them. Let's see how it looks like. So at this point, I have created a structure. If you see this structure, this is my commit. Okay, this is my commit. This is my first tree. This is my first tree, this tree here. This F2, F3, 9B, 0. Then inside that, I have got one more tree. What is that tree here? B71548. So this is my first tree, which contains my images directory. Then this images contain 2 more blobs. Okay. And then I have got index.html as my first blob here. And then I have got styles.css as my second blob here. So if I just put this commit IDs here, you know how it will look like. This is my first one. So I copy this. I go here, paste it. So 1267859. Yeah. Then this is nothing but my root directory, which is pointing to that root directory points to the tree. The tree here is what? F2, F3. Let me take this first 1, 2, 3, 4. Yeah. This many characters here. And okay. Then inside that I have got one more tree. That tree is nothing but my images tree. So it is what? B715483. I copy this. This is nothing but my tree again. This is my images directory, which contains 2 blobs. So first come back to the first tree, which was my F23, which I then, this was my internal blob. So let's take the IDs for the blobs now. C272, CA137. Let me copy this. So this is nothing but my index.html. and the other one is what, B757CB0F. Copy and I paste it here, and then I have got Git. And so let me take the first characters here, and let me take my first characters here. So these are my various blobs. These are my various blobs, and based on that, this is how my current commit structure looks like. Good enough to understand? These are all my blobs trees. So this reds are commit, greens are tree, and these are blobs. At this point, how many Git objects are created here? If I see 1, 2, 3, 4, 5, 6, 7. If I go and fire a command, git count objects, see, it is saying that we have 7 objects here. Yeah, it is saying we have 7 objects, 29 kilobytes, whatever it is. 7 objects, 29 kilobytes. Now, in my code, what will happen if I go and I make one more commit? If I go and if I make one more commit. So let me go and make the changes in my code first. So let's say in my styles.css, I find, what do I find? That this was my code. I don't like this color of blue. I want to make this color match something like this red color. So let's say I go to my header file in CSS and I say, let's not use this. Let me use Indian red. I make this change. Okay. I like this change. I do and make a commit now. So for that reason, but see, the moment I make the commit, I will keep my file open so that we understand what is exactly happening here. Git add space dot. Then I say git commit -m changed the header color. Okay, I have changed my header color. So this git commit happened. The moment my git commit happened, see, the number of file increased now. And at this point, if I say git log hyphen one line, so I have got one more commit here and I have got my commits. So these are 2 commits. And now if I do the same structure, I say git cat file -p, and if I copy this, what do I find? See, now it has added one more part here. It says that this commit have a parent, which is pointing to the previous commit now. Plus, I have got a tree. Now this tree have changed from the previous one. If you see the structure, my previous tree was starting with what, DAF3. So sorry, this is new one, but this was starting here. But if I open this tree, let's see what happens. If I say git cat file -p, and this time I say DAFEA3. Okay, so this time what has happened, if I compare it with the previous ones, so here my previous tree was starting with what, like internal tree, which was images tree. See, B71548, see, the same tree is reused here. Index file was what, 72CA1E7, see, the same one. Only thing that I've changed now is my styles.css. Why? It says 95A9562, which was changed. So in this particular commit, what has happened? Even if I open this tree, see, it's no use, but if I open that, you will find my SHA IDs are exactly same. So if I say git cat file -p, and if I paste my commit, you will see 49DE778 and FE934. So these files are exactly same. So what happened after the new commit? If I want to update in this graph, let's see how that happened. Okay. So for that reason, I'll do what, rather than making changes here itself, let me open a new file. So let me take it on a new file here and add a new commit. Yeah, add a new commit altogether here. So original files were in previous one, files were 7 objects. Okay, let us see how that changes. Now the moment I make a new commit, what will happen? A new tree will be created. So this part is more or less copy pasted, but the only thing is certain things will change. So this is my second, this was my commit. So the ID used here will be this one. So let's say I paste it, and this is parent for, yeah, this commit is parent for my previous commit. So the new tree is created here. So that tree ID is what, the new tree ID for this one is what DEFEA32, DEFEA32B, whatever it is. The new ID has changed. But inside that, inside if I open this file, you see the images is pointing to the same tree. So they are basically reusing my objects. So this is where my tree points to images. Plus, what has happened, my index.html, the blob which was pointing there, is still pointing to the same one. So I can see this tree internal blob is pointing to the index.html, but the only file that got updated here was my styles.css. So inside this tree now, what will happen? I will have a new blob of styles.css, and which is pointing at what? 95, this number. So I copy, paste it, and this is where my styles.css will be available now. So this is good. How my commit is stored. Apart from that, if you see, other all things remain same. So after this commit point, see, this is how it got updated. Now tell me how many objects are there. We have got two commits. Then we have got 1, 2, 3 trees. So they are 5, 6, 7, 8, 9, and 10. So I have got 10 objects. If I do git count, if I do git count objects, I find this time there are 10 counts objects. See, because why is this happening? Because they are reused. So the current value have got updated. Yeah, my current value have got updated. And so these are my 10 objects here. And yeah, so this is how internally when you make the changes into your commits, that's how they work. And I hope this video was good enough for you to understand that when you keep on adding commits, the changes happen inside your .git repository. And thank you for watching this video. I hope you got to learn something new from this. Please subscribe to my channel, hit that bell icon. Thank you for watching this video. Do share it with your friends.